Our next presenter has been the Kaggle community he's been winning medals for over half a decade. At this point, I think he's at 70 medals in Kaggle competitions. He has a background in everything from consulting to governmental work and to startups. So he has a truly wealth of knowledge, and at one point was ranked 8th overall in our Kaggle competitions leaderboard. As you can see, I know it's a very appealing topic with leakage. Those of us on the competitions team don't always want to have leakage in our competitions, but as Mike's going to be talking about a little bit more today, it can be a good thing sometimes. So please give a round of applause and welcome up Mr. Mike Kim.
Thank you very much. It's really an honor to speak at Kaggle Days at Google Next. And I guess the topic I'd like to talk about is a bit sensitive because leakage is very similar to bugs, right, in software engineering. And it's a subject that can hurt some feelings, bring down machine learning systems, give you bad predictions, and cause all kinds of issues. But also, understanding leakage from a competitor standpoint could help you win competitions without really writing that much code. So depending on where in the spectrum of software engineering to kind of data scientists you fall under, this might be interesting for different reasons. So yeah, I'm going to try to make this as interactive as possible just to get to better understand the audience and what do you guys think. So yeah, let's start. So right now, I'm just going to gather some data really about everyone here. And I'd like to raise your hand. Would you please raise your hand if you're a software engineer or consider yourself a software engineer by profession? Could you stand up? Sorry, it's difficult to tell right now. Trying to get a better count here. Okay, so there's a few of you. And just keep standing, but given you are in software engineering, please keep standing if there are 0 bugs. You've never seen a bug, your code is perfect, and your company's code is perfect. I would like to know which company you work for, and I would like to start another startup with you, if that's possible. That's really amazing. No bugs, and no bugs in a very large system. But usually, for the mere mortals, we write bugs. And it's unfortunate, but all your favorite projects, all the tools that we use, Keras, TensorFlow, XGBoost, LightGBM, all of these have bugs. And you can, if you go on GitHub or you go look, there's going to be a bunch of issues. There are really going to be a lot of bugs in the system. And they still work, but they're problematic, right? So I kind of like to think of the equivalent of bugs is for data scientists to be leakage. And it's one of those things that is very present in kind of the competitive community, but I'm also quite sure that it's very common at companies that use machine learning. So can you, anyone out there who's a data scientist, can you all stand up? So yeah, it looks like it's most of you. If there's no leakage in your system, please keep standing. In a system that you wrote or in a system that your company, really, a few people. So never had leakage, ever. Really? Okay, that's really interesting. It's really interesting because I've worked with a lot of Grandmasters, Kaggle, like the very top, including, I believe, first place and so forth. And all of them have at some time produced leakage in their own local cross-validation. So it's one of those things where I would say like pretty much everyone does it. It's just kind of a degree It's a matter of whether they do it often, or whether they have protections against it, where they set up good practices to try to prevent it. But I would say that it's one of those things where it's very difficult to prevent. And I want to keep this talk as positive as possible. It's really about learning from this concept of preventing leakage, understanding leakage, identifying leakage, and so forth. So, everyone leaks sometimes, right? You're going to have a bug or a problem in your experimental design, but you don't have to, right? You can learn from your mistakes, and hopefully next time you won't have that issue. So this is a quick overview of the rest of the talk. And again, I want to make this more interactive. So if you do have questions, I will take them at the end. We have a block set up at the end to take questions, but also if you have a question within the talk, I'll also be taking questions if you have a question on anything as you see fit. So the overview is I can go over the definition that I came up with, or I think I came up with. I didn't take it from anywhere. Some historical examples, exploiting leakage, so like feature engineering, leakage engineering, some correct experimental design. I kind of use that term loosely. And references and questions. So that's kind of how it goes. And this is my definition. Leakage is when information concerning the ground truth is artificially and unintentionally introduced within the training feature data or training metadata. So this is quite broad. Some people think of leakage as like future information or something specific, but I'm saying really anything that you don't want there, which is somehow correlated with the ground truth, whether you know it or not. And it's actually really interesting that certain things can correlate with the ground truth, like date timestamps of your folders. Some people will use that. That's been used in competitions. Or if you have multiple files and tables, the order of the records in each of those tables or the relationships. So it's actually, it doesn't always exist in the purely, it is already in the feature space or it's a time series problem. I think most people are more familiar with those types of leakage, but it really is kind of a lot more general, or I consider a lot more general. And that's kind of from the experience of exploiting it or looking for it. And at a certain point in time, it was more of feature engineering, and then somehow you would stumble upon leakage. But I think at a certain point in my Kaggle career, it was more of, well, I'm not even going to bother. Someone accused that I was looking for leakage. At that time, I wasn't, but I thought he had a really great idea. So I said, well, this time I didn't. I just was feature engineering, and it was a gray area. But you bring up a really good point, Kaggle Grandmaster. I will take your advice. And instead of feature engineering, I will leakage engineer. And that's pretty much what I did for a lot of competitions, was just look for the bugs, really. And I think there's kind of two ways to go about this. You can kind of take this talk as ways of trying to win Kaggle competitions through leakage, which is completely within the rules, usually unless they say don't use it. Or the other way is to kind of understand these concepts and then put kind of tests or a process around your software engineering so that you don't make these mistakes, right? So if there are simple ways to make sure that you don't fall into these traps, like use a secure hash, shuffle your rows, always shuffle, shuffle your train, shuffle your test rows, make sure that there's no correlation between the ground truth and some oddball feature that should not give any lift. And I think that's kind of the two ways you can go about it. So I have some historical examples here. I would say that for whatever reason, it isn't always the case, but sometimes combining train and test into a single data frame will allow you to better exploit leakage. But that's not always the case. Sometimes train and test should be separated, and then like a really simple example is, let's say all the positive examples are on the even rows. You have the same shape. So you have two data frames of the same shape, your train and test split. And all the even rows of train are the positive examples, and the odd rows are negative examples. And it's a binary classification task. Well, that actually might hold for the test set as well, and you might achieve a very good score, perfect score. And I believe that's happened before. You can correct me if I'm wrong. But even simple things like that can be quite telling of the kind of the systems behind it, right? So even or odd row is not something that a machine learning algorithm can see unless you put it in there. And it shouldn't really have any bearing on actually making good predictions, right? So usually there's no time order or anything like that. So these are kind of like the types of leakage features that I'm trying to talk about, right? And I think there's a lot of kind of weird features that shouldn't exist in terms of row order. And I think they're not as simple as even or odd rows, but sometimes your data comes with a natural order, like a time series-based order in the rows, which are not actually, it's not given to you by the organizers, but you can exploit it. And it's one of those things where when you think of machine learning as, I'm just going to put something in this black box, it could be a GBM or neural network or random forest or whatever, and get a result, well, a lot of these things won't be caught, right? You need people trying to compete to really find these things, and people who are willing to do foolish things or things that they shouldn't do, right? So if you tell a beginner, oh, I'm going to use the order of the rows or something like that, they would say, why would you do that? That doesn't make sense. But if you've been competing on any number of machine learning competitions, not just on the Kaggle platform, you would realize that a fair number of machine learning competitions, not only on the Kaggle platform, but overall, they have this problem where there will be some type of nonsense feature, a feature that really has nothing to do with the actual task at hand. There's no, if you gave it to a subject matter expert, they would say this shouldn't work, but it does. And I think that's kind of where this idea of understanding leakage and exploiting it becomes really kind of both powerful and also something that really is kind of difficult to grasp. So I'm going to kind of talk about each of these in order across some Kaggle competitions. So all of these right here that you see, like column order, a time series chopped up in rows and columns, they've all, like these things have happened on Kaggle across different competitions. Okay. So this is one of the first competitions that I was part of, which is the lone default prediction by Imperial College London. And this competition had I believe it had a reset, and a new train and test data was released, and it was found there was a golden feature, basically. It could have been leakage. No one really knows, or maybe very few people know. But it was posted on the forums, and if you use these two features and just put in a GLM, you'd get a really high score. That was really top of leaderboard. And I think this is kind of the gray area. Was it leakage? Was it a golden feature? And I think from both a software engineering and data science standpoint, if you do have a production system and you're in this company, then you really want to dig down. But at this point in time, in a competition, you just want to exploit it. So no one really knows, but it's not always clear whether your feature is just really good or it's leakage, a bug. So one of the most common forms of leakage is row order. And this kind of thing shows up again and again and again in different forms. They're not always the same form. And the one that I competed in was the Telstra network competition. And it was like a recruiting competition where the order, there were multiple tables. So it was a little bit more complicated than a typical single train tests, CSV type format. There are multiple CSVs, and you can join them together, and they all could be used in different ways if you merge them together to predict this binary ground truth. I believe it was 0, 1. The issue was that in some of these files, not all of these files, the order of the observations mattered. Or if you ranked it by some column and then you sorted it, the order mattered. And a lot of these things shouldn't happen, right? Like, why should the order matter in this CSV? It shouldn't, right? So I think kind of there's one way to approach it is to shuffle everything. But sometimes, even if you shuffle it, let's say that there's a time order and then there's a time column, it may not be leakage because you could order it by a certain column. You can sort by some key, and you'll get that order. So it's really kind of difficult. And I want to point that out because I don't think just shuffling, so if we say shuffle everything, it doesn't always solve the inherent problem of leakage. It really depends on kind of what the features are and the actual problem you're trying to solve. So there was another competition, the Bosch production line competition. And this was also a competition where the order of the observations mattered. And then there was, I believe, like a time component to it. And you'd get duplicate records. If you just looked at the data, if you looked at one of the CSVs, you'd see the duplicate record, triplets or doubles of records. And that was a very predictive feature. So I personally used, I believe, a few kind of easy to implement features, which were just, I looked at the rounded row index as a percent, and I combined it with the feature, and then I did a count on that. So it would be basically a value count with row order in there. And apparently that worked. There were better approaches that kind of chunked up the data with respect to where it was in the CSV that gave much better scores. But really, kind of, I think the point of this really simple approach is that you can test for leakage. So you can have something like unit tests, but unit tests for leakage. So in your competitions, when you're running competitions, you may want to have a number of basic kind of tests to go through to make sure that the very simple ways of leaking aren't present. And I think combinatorically this becomes very difficult because a lot of these kind of sort by some feature and then diff some column and then group by and count. Well, if you have many features, then it's going to take you a very long time to run these tests, right? Combinatorically, it blows up. But I think it can still be done, and it would probably save a lot of kind of time in terms of competitor time. If competitors compete, they find a leak, and then it gets reset and so forth. I think that is from a Kaggler's point of view, it could be difficult, right? Because you spent time on it, you found the leak, and now you want to win, or do well, but now you can't. So if the leak wasn't there in the first place, then you might not have this issue. Okay. Oh, so I think another solution to this that Kaggle implemented recently was they have actual forecasting competitions, right? So Kaggle has had March Madness. That was I believe, one of their initial forecasting competitions. And there's no way to really leak there, right? I mean, you're using historical data, and then your predictions get played out through time. Unless you know something about the future that no one else does, it's a fair game, right? So Kaggle's been doing that, and I think that's really awesome with more than just March Madness. So March Madness, I believe one of them ended, either the men's or women, I think it ended, and it's going to end this week. So yeah, I think that's really great. And we're having competitions like that with, I believe, 2 Sigma has had a stock forecasting competition, and it's being played out right now. So this is a way to kind of prevent leakage or sidestep the issue of leakage. Well, you're not going to leak anything, right? Or you might have leakage, I guess, in your training data, but you wouldn't be able to exploit it in the competition. So in terms of actually winning a competition through leakage, it's not going to happen in these forecasting competitions. You put the burden of understanding leakage in the training data partially or more on the competitors. So if there are leaks, well, you shouldn't use them because it's not going to help you. It's not going to help you predict the future, which is going to happen later, and you're going to be scored later. So that's probably one of the best ways to test it. But I guess there's a cost of, well, you're paying the cost of time, right? So I think one of the other ways of leakage, or kind of like a gray area that's been used in competitions, is leaderboard feedback. And sometimes you're able to kind of put trends together using the leaderboard or mining the leaderboard. You can also retrain your models using the public leaderboard. So I'm not sure if this is always legal. I don't know how it's evolved since back in the day. So like the most famous competition where this was used, or like the first I can recall, was the West Nile, the mosquito competition. I don't know if any of you if you were in the competition, but there was a way to kind of basically mine the public leaderboard, and that would give you real information to help you win about kind of the trends of like mosquito, West Nile, right? West Nile virus. So I mean, it's very difficult. I think this kind of shows that designing competitions is pretty hard because you have a lot of people who are willing to do very weird things that you might not normally think of, right? If you ask me, would this have happened before the actual competition, I would have said, it doesn't seem like it, right? I mean, why would they do that? Why would these Kagglers spend so much time, like making submissions and then getting feedback and then changing their models? But that actually happens. It's happened before and it happens again, right? So there were even competitions where people were able to mine the ground truth and then using public leaderboard feedback, find out which examples were public on the public leaderboard and the private leaderboard, and then retrain their models using the ground truth they got from the public leaderboard. So competitors are going to do whatever, right? Like, as long as it's within the rules. And I think that's what makes this it's like a very interesting type of game, but also it's very difficult for, I guess, the designers or the Kaggle team to really kind of predict the kind of strange behavior that Kagglers will engage in. That's not right. Okay, so this is actually something I think it happened in a competition that I did pretty well in. It was the 2 Sigma rental listing. And the leak there was that the metadata, so the folders, had a datetime attached, a creation datetime. And that correlated with the ground truth. So you could use that feature and heavily exploit something that isn't actually it's not even in the CSV. It's not even row order. It's something that was in the file system, right? The folder creation time. So that presents a problem because, like, if you're designing this, if you're designing a pipeline that will not have these issues, then you have to randomize the creation of folders, or it kind of you have to do some weird things. I guess you could shuffle the data and then create, but it may create some problems if it's a legitimate feature as well, right? You create them as things occur, and then there's a trend in time that towards one direction, right? So I think things like that make it make it difficult on the people organizing the competition. Okay, so I'm going to here talk about some potential leakage, and usually when I think of leakage, I just think of what a GBM can't see, right? Like what a decision tree can't see. And there are a lot of things that a decision tree can't see. But most of them are nonsense, right? Like the order of the digits. So is this a categorical feature? You have maybe a numerical feature. It looks like a typical float or something, but it's actually a categorical feature. So it shouldn't be, in that sense, I guess a GBM would see it, but like maybe okay, so here's one that a GBM wouldn't see. If you did something like a cumulative count on a float, it wouldn't see that, right? It doesn't know because the cumulative count just goes through and then it updates the counter and that's not a feature in there, so it wouldn't know about that. Another type of thing a GBM wouldn't see is if you go through a feature and if you see it the first time, you label it with a 1, or you start a counter. And then if you see it for the second time, you still label it at 1. But if you see a new unique, you label it with a 2, or something like that. That's also something a GBM wouldn't see. So there's quite a large range of kind of nonsense features that you can create, really an endless amount, right? I guess the sum of the digits, that I don't know how that could be leakage, but it's a nonsense feature, right? A GBM wouldn't know that. Yeah, so I think one of the ways of preventing preventing leakage is testing these each individually and seeing if you get lift or not. You should get very little lift, probably almost 0 lift, right? It should be random noise. But if you do actually get some high lift from this, then it's probably some type of leakage. Yeah, so leakage engineering is you think really hard and you think of what a GBM can't do. Because a GBM could do whatever, or if you like neural networks, what a neural network can't do. And a neural network would be a universal approximator, so it could see anything, I guess, within the function space. So it can't see things like you don't give it. So, is Jeremy in the room? No? Yes. I think Jeremy is probably the greatest data scientist in America. Competitive data scientists. I think it's true. So he's won many competitions. Won this particular competition through exploiting leakage, which was the Expedia hotel. Could we hand the mic to, would you like to say a few words about it? No, go ahead. You have to make it hard. Okay, so correct me if I'm wrong, Jeremy, but the Expedia competition had distances between cities or hotels, right? Hotels. And this was a leak that was confirmed by the organizers. And you were able to magically place, using just these distances, given a new pair, you would actually know where exactly these cities are on the globe. And that's amazing, right? Some black magic, some crazy stuff, right? I believe you used a factorization machine and SGD?
Yeah, that's pretty much most of it. The SGD was for placing the hotels on the globe, and the factorization machine was just due to the nature of the problem.
So I thought when I saw that, I thought that was amazing. And a lot of people were trying to crack it. So I believe I was trying to do it as well. But it's one of those problems where you think, maybe you could think, oh, they're not going to do that, right? Who would do that? But there's a lot of really good data scientists who will do that, and they'll figure it out. So really, props to Jeremy. Won first, and really kind of exploited leakage. Did that happen? Did that competition ever provide any value for Expedia, though?
Yeah, it did, in the sense that I made them aware of field-aware factorization machines, which up to that point they were just using the ordinary ones to program them. But the leakage itself
So that feature shouldn't exist in a production system. Is that correct?
No, you're not going to know the exact distance down to the inch of where they're going to book a hotel. So this is definitely something which is not useful.
So I guess they learned, I mean, you provided them value in a few ways. And I think from the competitive standpoint, we all learned from you, which was quite valuable. But also, I guess they learned not to put that as a feature in their, in their internal, when they build models internally, right? So, yeah. So that was a very interesting competition. It's a little bit complicated. If you'd like to take a look, if any of you all would like to take a look, it's the Expedia. I posted that right there. Yeah, so I have some basic kind of things to consider when setting up a competition. And I believe some of these have already been implemented by Kaggle. And something like strip all metadata if possible. So if you have images, strip all the metadata because I'm going to be looking for that metadata. And if there's metadata, I'm going to use it. So I think Kaggle has been pretty good about doing this. And I haven't been able to find anything useful. Sometimes file size and date created can also help, but I think you can also anonymize or strip that as well. I would also randomly shuffle all the rows and the columns of the train and test so that you don't have any kind of weird row-based feature. So any kind of way of getting an ordering of the rows, I would think of any kind of way, from shuffling to whatever, to make sure that it's not possible. And I wouldn't suggest putting in artificial data to try to, because for some reason, Kagglers can try to reverse engineer, and sometimes successfully, that you put in synthetic data. So I mean, synthetic data, I guess you can put in synthetic data, but I would expect that people would figure out which data is real and which data is synthetic. And in terms of testing, I would suggest the fast method, like a random forest. Something that requires little tuning and that could run without, just run in parallel, run all the time. Because I think part of the difficulty of implementing these solutions in a production system, it really has to do with the fact that this is expensive computationally, right? So when Kaggle was a startup, correct me if I'm wrong, this would be a very difficult, a decision on their butt. It would cost a lot of money. So they would have to make that trade-off. But perhaps now with the backing of Google, maybe this is a more reasonable solution. So using Google Cloud or Google Compute, GCE or whatever, to have these tests run. And I think that is a huge advantage of Kaggle over other competitions, is that probably a lot of these other competitions, they don't have the resources to test for all of this leakage. Because it costs money to spin up the cores, run a random forest. And think about, you have to run it every single time like a unit test, or every single time you'd want to deploy it. So it's something that's costly, and it makes sense that in the startup phase, this would be very difficult to do, or it would just cost money that the founders may not want to put into it. But I think as the organization matures, it might be useful to put in these tests and pay the kind of the cost of running a random forest every single time, checking for these leakage in a computationally expensive way, right? Trying all the combinations, sort by this, diff by this, do that, do counts by all these tuples. It'll cost a lot of money, but I think in the end, it really helps make competitions legitimate and fun. So although I guess I have fun trying to find leakage, but I would say some people don't. So yeah, I think Kaggle already does pure forecasting and two-stage competitions, and they've been doing that for a while, and I think that does help reduce leakage, or at least put the burden of understanding leakage on the competitors rather than exploiting leakage. So these kind of new types of competitions, I think they're difficult for the old school to accept, but I think it's the right direction in terms of making legitimate competitions so that they make good predictions and there's no, there's no leaks or bugs. And from a standpoint of a competitor, a lot of competitors leak when they do their cross-validation. And this is kind of different from Kaggle leakage. What I'm talking about here is that Kaggle competitor will set up their cross-validation, and they think they have a really good, they think, oh, it's a really good score. I'm going to win this competition. But it turns out they were leaking internally, so within their folds, or they had the ground truth, or they're doing some kind of mean encoding, Bayesian encoding, and they're leaking. So one simple way to kind of prevent this type of leak from a competitor standpoint is to set up their own Kaggle. So take out 5% of the data, or a very small amount of the data, and never use this data. In fact, split it out and put it away so that it can never leak into any of your folds, never train on this data, ever, right? This is like your own leaderboard, and then you might do an occasional peak, right? So you say, okay, now I think this model is really good, so let me check. And if you actually hold it out correctly, so you take it out, you never train any of your meta models, you never do anything with this data, you treat it just like a Kaggle test, right? Then I think internally, as a competitor, you'll have a better, it's much harder to leak. So in terms of best practices, especially if you have to join to it. So I know a lot of top Kagglers use this approach. Several Grandmasters I know personally, they all do this. So it's one thing with setting up your local CV is you do pay that cost of like the 5 to 10%. You're not using it ever, so you lose some power. But at the end of the day, you have to make that trade-off, right? So if you lose 10% of the data, then is that okay? Is the data big enough? And kind of what you gain from that is that it's pretty hard to leak, at least internally, when you do that. If you do a correct split and it's split by this correct thing, right? So it may not be a random split is what I'm saying. Oh, so I have some references here.